Okay, so now this is the same video with 6.1. In the case we're simplifying radicals with indices of 3 and 4. Our index has changed now, and now we're going to throw in some variables as well. Okay, so again, process with doing these problems is the same as square roots. Except on this one, in this case, we want to make sure everything is to the fourth power. So 80. I break down 80. 8 times 10. 10 goes to 5 and 2. 5 times 2. 8 goes to 4 times 2. And 4 is 2 times 2. Okay, so again, I want powers of 4. Now, as you look at the numbers over here, okay, on the numbers, we've got on the numbers here, we've got 1, 2, 3, and 4 twos, and then 1, 5. So again, I want fourth roots. So I want fourth powers here. So I've got a 2 to the fourth power times, that takes care of all my 2's, 5 to the first power. Okay, then m to the second, I'll never be able to make that a 4, so we're just going to leave that guy. Then n to the first, and then p to the fourth. Okay, so now process again is the same thing. Anything with a fourth power is going to be outside the root. Anything without a fourth power is going to stay on the inside of the root. So 2 to the fourth, it has a fourth power, it goes on the outside. 5 to the first does not have a fourth power, it stays inside. M to the second does not have a fourth power, so it's going to stay on the inside. N to the first does not have a fourth power, it's going to stay on the inside. And then P to the fourth, it has a fourth power, so it's going to move to the outside. So my final answer here, when I multiply everything together, I get 2p times the fourth root of 5m squared times n. And that is my final answer. Okay? So this is a good example of a problem where you have the index here is 4, so I need to match up fourth powers with it. Okay, this example here has an example of a third root, so I need powers of 3 this time. Okay, and then I got to break down 192, and 192 is going to give me 16 and 12. So again, 16 and 12. 16 goes to 4 and 4. 12 goes to 4 and 3. 4 goes to 2 and 2. And then this 4 goes to 2 and 2. And then this 4 goes to 2 and 2. Okay, so totally here, I have 1, 2, 3, 4, 5, 6 2's, and I have 1 3. Now again, I only need 3 at a time. So when I write this here, I'm going to take 3 2's, 2 to the third. 3 more 2's, 2 to the third. And then I'm going to take a 3 to the first. Okay, now then what I have to do now is I have to look at my letters. I have an x to the fourth. That's more than 3. So I can break that x to the fourth apart into x to the third and x to the first. And then I have a y to the first at the end. I can't break that one apart. Anytime my power is more than my index, I'm always going to break it apart to make it match that index, and then whatever I have left over. Okay, so now, as I look at this example, again, some things are going to stay inside, some things are going to move outside. This 2 is going to move outside the root. This 2 is also going to move outside the root. The 3 is going to stay inside because it doesn't have a power of 3. X moves to the outside because it has a power of 3. The next x stays inside because it has a power of 1. And the y stays inside because it has a power of 1. So 2 times 2 becomes 4, and then I have an x times the cube root of 3x and y.
Okay, so there.
As you look at that again, you should be able to complete the rest of the problems on page 3 of your 6.1 day 2 examples, being able to simplify radicals with an index of 3 or 4.